All right, in this video, what I'm going to do is use L'Hopital's rule for an indeterminate power. We see that this limit consists of a function of x, and that it's a function of x raised to a function of x. All right, so the base, this quote base of this exponential expression is 1 over 1 minus x. Now, as x goes to infinity, 1 over x goes to 0, so I have 1 minus 0 equals 1. So that's the limit of that base of that exponential expression, while the limit of x as x goes to infinity is equal to infinity. So this is a 1 to infinity indeterminate form. And okay, the reason I would say it's an indeterminate form is if you this is just a little aside, which I guess I'll erase, but if you add like 1 to a, whatever that is, 10,000 power, that's 1. But on the other hand, if you look at the limit as of 1.01 to the x power as x goes to infinity, that's an exponential function with a base greater than 1. That's infinity. So it's not clear what's going on. And on the other hand, if you add the base is like 0.99, for example, and x goes to infinity, that limit would be 0. So these things are working against each other. If the base is exactly 1, which it isn't because it's a limit, then you get 1 to whatever large number is 1. So on the other hand, if the base is just a little bit more than 1, you get infinity, a little less than 1, 0. And but the base is not fixed. It's not fixed as 1, and it's not fixed as a little bit greater than 1. So that's why it's an indeterminate form. And this one I think I could have improved maybe, but it doesn't really matter that much. Same idea. I could write limit 1 to the x goes to infinity. So like 1 to 1,000, it's 1. So, okay. So this is just like an aside, a remark, just to give you a feeling for why this is an indeterminate form. All right, now what I'm going to do for this guy is I'm going to do this little technique, which I'm tempted to call a trick, but I guess that's not really the right way to say it. It's a technique. And what I'm going to do is I'm going to write e to the ln of all this stuff. What is going on with that? Why am I going to do that? Okay. What the heck is that about? Well, it's about the fact that e to the x and logarithm x are inverse functions, and they actually would cancel each other out. So what I've done is I've unsimplified this. This is not simplified, it looks unsimplified. Okay, but I want it unsimplified. Why? Because I like logarithms. Not just because I'm weird, which I am, but because I have a nice property that we can use with logarithms. And what I'm going to do is I'm just simply going to find the limit of this ln part here. This ln 1 minus 1 over x to the x. I'm going to find that limit. I'm going to figure out what that is, and say the answer is 5, then my answer is, I'll put all that stuff in the green box. If the limit's 5, then my answer is e to the 5 power. Okay, if the answer in that green box is 7, then my final answer is e to the 7th power. So this in the box is what? Well, I have the ln 1 minus 1 over x, and this piece here, this x, comes to a front. Well, that's a property of logarithms. Okay, you're just going to have to believe that's true. Go back and do a proof somewhere, but that's a property of logarithms. Now, what's going on is the limit of x is infinity. This logarithm part becomes, if I take the limit of 1 over x, I get 0, so I have 1 minus 0, which is ln 1, and that's 0. So I have a 0 times infinity form. Okay, what I'm going to do is I need to write this as a fraction. And the way I do that is I leave ln 1 minus 1 over x up here in the numerator, and I bring this x into the denominator as 1 over x. So just like another remark, maybe this will make it clear, but maybe not. 2 could be written as 1 over 1 over 2. For the same reason, x can be written as 1 over 1 over x. Of course, 2 is more simplified than 1 over a half. Now, what's the deal here? Well, 1 over x we saw goes to 0, and the numerator approaches ln 1, and that equals 0. So now we have a 0 over 0 indeterminate form, which is a green light for L'Hopital's rule. However, before I do the L'Hopital's rule, I'm going to express 1 over x. Oops. I'm going to express, I'm not doing L'Hopital's rule, I'm just writing 1 over x as x to the minus 1 power. Why? Because that's an easier way for me to write the derivative, or to find the derivative. I'll use the power rule. Unless you've memorized the formula for the derivative of 1 over x, which to me makes sense to do. But, okay, let's go ahead and take derivatives. ln, it's for derivative ln, I use the chain rule. It's 1 over everything inside times the derivative of what's inside. The derivative of 1 over x minus 1 is, okay, so for logarithm, it's 1 over everything inside times the derivative of what's inside. Derivative of 1 is 0. Then I have negative, that's not the way to do it, maybe negative 1 times the derivative of x to the minus 1, which is negative 1 x to the minus 2. In the denominator, same, derivative of x minus 1 is negative 1 x to minus 2. And what we see is we have cancellation. So that works out nicely. That's the whole idea, is that these problems are supposed to work out. I'll just simplify this just a little bit. I have negative 1 times 1 is negative 1. In the denominator, I'll go back to writing this 1 minus 1 over x. So this makes x approaches infinity, so 1 over x approaches 0. Negative 1 over 1 minus 0, so this is negative 1. This is our sort of intermediate answer, I'll call it. All that stuff in the green box, oh brother, is my green box going to work? All that stuff in the green box, that limit is negative 1 of the stuff in the green box. But what I want to find is the limit of e. I want to find e to all that stuff. So the answer in the end is e to the minus 1, e to what was in the green box. If you want, you can write 1 over e. So that's our final answer. And, I could have gone slower and gone over more stuff a little more slowly, but I think there is something that people like, a little bit of a quicker video. This is from Openstax Calculus, Volume 1. It's problem 395 under L'Hopital's rule. And get that open source, free textbook, Openstax, Access, the Future of Education. Get that on the internet at openstax.org. Google it. Or DuckDuckGo it. Okay, take care. Goodbye.